Hello everyone, Mr. Fawcett back here for part 3 of our Understanding the Derivative lesson. We will try to squeeze in the last 2 pages, but we may have to make this 4 parts. Regardless, we're going to be going down to page 4, starting with question 16. Okay, so it says the derivative of a polynomial function f of x is given by the equation f prime, and then it gives us 3 factors that are shown. And we're going to use this equation to answer questions 16 to 20. So first question says, on what intervals is f of x increasing and decreasing? And justify your answers. So like we've seen in the previous videos, when we're asked for increasing and decreasing intervals, it's nice if we have a little number line that shows us where the derivative is positive and where the derivative is negative. Because if we know those intervals, well, we can easily know where the original function's increasing and decreasing. So polynomial function, so domain of both the function and the derivative is negative infinity to infinity. Now we need to find the zeros of the derivative so that we can mark them on our number line. Now I put 3 there because I know that there's going to be 3. But if we look at this derivative equation right here, it's nice because I already factored it for us. So we know that our 3 zeros occur at 0, 2, and, well, that's what I get for assuming they're going to go in order. I get 0, 2, and negative 3. Now, I still need to figure out what sign the derivative is in between those values. So I'm going to pick a value in between each or on each of those intervals. So I'm going to do f prime of negative 4. I'm going to do f prime of negative, negative 2 is okay. It's really up to you which number you pick on the interval. Oh, well, I said negative 2. Well, I think we'll just stick with that. I'm going to do f prime of 1 and then f prime of 3. So we have 4 different intervals here, which means we need to test the derivative 4 times. So if you haven't already paused the video to answer all of these questions, do that now. Start with this one, find the values, those values of f prime, fill in your number line, and see if you can answer the rest of the questions as well. So for f prime of negative 4, we get positive 24, which means this interval, on this interval, the derivative is positive. For f prime of negative 2, we get negative 8. So on this interval, the derivative is negative. For f prime of 1, we get 4. Derivative is positive in that interval. And f prime of 3, we get negative 18. So the derivative is negative on this interval. So if we come over here and answer the actual question, f of x is increasing on the intervals negative infinity to negative 3, union 0 to 2, because f prime of x is greater than 0 on these intervals. You must have the justification to go along with your answer. Otherwise, you're only going to pick up half the points on the AP exam. Let's talk about where it's decreasing. So f of x is decreasing on the intervals negative 3 to 0, union 2 to positive infinity, because f prime of x is less than 0 on these intervals. Okay, number 17. At what values of x does the graph of f of x reach a relative minimum? Okay, I will go through this diagram one more time. I know you're sick of seeing it, but I'm really trying to hone in and have you understand these relationships dealing with derivatives and original functions so that you don't have to think about these too hard later on in the course. You know, these want to just you just want to be like, oh, okay, derivative is this. That means this is going on with the original function. Or, oh, we have a relative maximum. Okay, I know that the derivative is doing this. Spend the brain power now to think through these every time so that later on you can focus on the newer concepts and not have to go back and constantly think about these old relationships. So for relative minimums, right, if I have a function with a relative minimum, and note that the function does not have to be a parabola for us to have a relative minimum. I can also have a function that looks like, I'll do it over here, this, and this is also a relative minimum. That being said, regardless of what your relative minimum graph looks like, our derivative is going to go from negative, that tangent line has a negative slope, to positive. And it's the same as if our graph looks like an absolute value graph, like the purple one does. Our derivative starts off as negative, and it ends up as positive. Okay, those tangent lines just end up being the same as that piece of the graph. But again, let's be clear, both of these are relative minimums. They just look different. So if we're looking for the x values where f of x has a relative minimum, we need to look for where the derivative goes from negative to positive. And that's going to occur only at x equals 0. So at x equals 0, because f prime of x goes from negative to positive. Relative maximum is just the opposite. I'm not going to draw relative maximum graphs. You would just flip these two that we already have. But for relative maximums, the derivative goes from positive to negative. So that's going to occur at x equals negative 3 and x equals 2. Again, don't forget that justification, because f prime of x goes from positive to negative. So this number line tool up here is super helpful, not only for increasing and decreasing intervals, but for understanding which horizontal tangents or which spots at where the derivative is equal to 0 are relative minimums and relative maximums. Okay, I am going to erase what we have, and then we're going to work on the last two parts. I believe we have 19 and 20. Yep. So number 19 says, what is the equation of the tangent line drawn to the graph of f of x at x equals 4? So again, this is going to be our work for number 19. If they're asking us to write the equation of a tangent line, we're just going to start with point slope form. Y minus y1 is equal to m times the quantity x minus x1. Our x1 and y1 are given because they tell us that f of 4 is negative 1. So y minus negative 1, which will be y plus 1, is equal to m times the quantity x minus 4. Now we still need to figure out what that m is. But m is the slope of the tangent line, and we know that the slope of the tangent line is another way of saying derivative. So let's find the derivative value at x equals 4. Well, we have no table or no graph, but we do have the algebraic form of the function. So let's just substitute 4 in for f prime. F prime of 4, or sorry, substitute 4 in for the x in f prime, is going to be equal to 4. 2 minus 4 is going to give me negative 2, and 4 plus 3 is going to give me 7. So f prime of 4 is going to be equal to negative 8 times 7, which is negative 56. So our m is negative 56, and that would be the equation of the tangent line at x equals 4. Question 20 asks us to use our tangent line. So I'm going to leave the equation of my tangent line up, and I'm just going to scroll down so we can read the question real quick. So it says approximate the value of f of 4.1. We're going to use our tangent line to do that, and explain why this is a good approximation of the true value of f of 4.1. So actually, I can just leave this here. So f of 4.1, I'm going to substitute into the equation for my tangent line. So y plus 1 is equal to negative 56 times the quantity 4.1 minus 4. Do some simplifying. I get y plus 1 is equal to negative 56 times 0.1, which gives me y plus 1 is equal to negative 5.6, and then I subtract 1 from both sides, and I get y is equal to negative 6.6. So this is approximately equal to f of 4.1. Now, think about, we did this a couple of videos ago, but we said the tangent line provided good approximations of the function as long as the x value was close to the point of tangency. So our tangent line right here, that was made with a point of tangency at x equals 4, right? They were saying draw the tangent line to the graph at x equals 4. So this value right here, 4.1, that x value is close to 4, so the tangent line is going to be a decent approximation. If they said find, or if they said use the tangent line to approximate f of 12, well, 12 is very far away from, it's much farther away from 4 than 4.1 is, right? So it's going to be a far less accurate approximation. But 4.1 is close, so we can say it's a decent approximation. You do want to mention, though, in your justification that 4.1 is close to 4. So I just put down that this is a good approximation because 4.1 is close to the x value of the point of tangency, which was x is equal to 4. Okay, I am going to stop the video here, and we will come back for a fourth part to finish off the last page. I just don't want to push this video past 20 minutes. So hope to see you for part 4, but as always, regardless, enjoy the rest of your day.